Ever wondered what biomaterials are and how they are used in our daily lives? Well, let's dive into this fascinating world. Biomaterials are essentially materials that are designed to interact with biological systems, and they can be either natural or synthetic. Some examples include metals, ceramics, polymers, and composites. What's incredible is that these materials are more common in our lives than we might realize. Every day we encounter biomaterials in various forms. Contact lenses that help us see better. Those are made from hydrogels, a type of biomaterial. The dental implants that replace missing teeth, they're usually crafted from titanium, another biomaterial. In essence, biomaterials are the unsung heroes of many medical advancements, quietly supporting our health and well-being in countless ways. From the mundane to the miraculous, they are integral to our lives, shaping and improving them in ways we often take for granted. So biomaterials are literally everywhere, but how did we get here? Let's find out in our next segment. To understand the significance of biomaterials, we must first look back at their humble beginnings. Now take a journey back in time, where the first uses of biomaterials were as rudimentary as the era they were in. In the early days, biomaterials were naturally occurring substances, simple yet effective for their time. Wood, for instance, was a common choice. Its durability, ease of carving, and wide availability made it a popular choice for prosthetics. In fact, the earliest known prosthetic, a wooden toe found on an Egyptian mummy, dates back to somewhere between the 15th and 12th century BCE. Bone, too, was a go-to material. In ancient China, animal bones were sharpened and used as acupuncture needles, an early testament to the use of biomaterials in healing practices. And in the realm of dental care, civilizations were not far behind. The Mayans, for instance, used seashells and jade for dental implants as early as 600 CE. Leather and silk, materials abundant in nature, were also used. Leather's durability made it suitable for braces and supports, while silk's strength and flexibility led to its use in sutures. These early humans, in their quest for survival and betterment, turned to nature for solutions. They may not have known it then, but they were the pioneers of biomaterials, setting the stage for a revolution in medicine. However, these early materials, while innovative for their time, were not without flaws. They lacked the ability to integrate with the body, often leading to complications like infections and rejections. Moreover, their functionality was limited. A wooden leg is a far cry from a natural one. Yet these limitations didn't stop progress. Instead, they spurred on the quest for better, more advanced biomaterials. Through trial and error, through centuries of innovation, we've arrived at today's sophisticated world of biomaterials. Even with these early endeavors, the true potential of biomaterials was yet to be realized. And realize it, we did. But that's a story for the next scene. As science progressed, so did our understanding and utilization of biomaterials. The 20th century marked an era of remarkable advancements in the field of biomaterials. This period witnessed the discovery of new materials that would revolutionize medical science and give rise to a new era of healing and restoration. One of the most significant discoveries was silicone, a versatile and biocompatible material. Silicone was found to have a wide range of medical applications due to its flexibility, durability, and resistance to bacteria. Its ability to mimic human tissue made it an ideal choice for a variety of medical devices, from implants to catheters. Silicone has been instrumental in the development of prosthetics, giving amputees the chance to regain mobility and live more fulfilling lives. In tandem with silicone, another material made its mark in the medical world: titanium. Known for its strength and lightweight properties, titanium became a game-changer in the field of orthopedics. Its excellent biocompatibility and resistance to corrosion made it an ideal choice for joint replacements, dental implants, and even surgical instruments. These materials, along with others like polymers and ceramics, opened up new possibilities in the medical field. They led to the development of artificial organs, drug delivery systems, and even bioengineered tissues. The impact of these developments was far-reaching, transforming the lives of millions of individuals worldwide and changing the face of healthcare as we knew it. But these discoveries were not just about the materials themselves. They also led to a better understanding of how the body interacts with these materials. This understanding paved the way for the development of more sophisticated and personalized biomaterials designed to work in harmony with the body's natural systems. It is fascinating to see how far we have come in our understanding and application of biomaterials. From rudimentary usage in ancient times to the high-tech applications of the present day, the journey has been nothing short of extraordinary. And yet, we are just scratching the surface. These advancements were only the beginning, setting the stage for a new era of biomaterials. Welcome to the 21st century, the age of bioengineered materials and regenerative medicine. In this era, biomaterial science is experiencing significant advancements. We're witnessing the creation of materials that can interact with biological systems, leading to cutting-edge applications that are pushing the boundaries of possibility. First, let's talk about bioengineered materials. The term might sound like something out of a science fiction novel, but it's very much a reality today. Bioengineered materials are designed to mimic natural tissues, often using cells and proteins to create materials that can replace or repair damaged body parts. These materials are not just inanimate objects, but living dynamic systems that can grow and adapt within the body. It's a fascinating blend of biology and engineering that's paving the way for a new era in healthcare. One of the most exciting developments in recent years has been the advent of 3D printed organs. Imagine a world where a patient in need of a heart transplant doesn't have to wait for a donor, but instead can have a new heart printed on demand, tailored to their specific needs. That's the promise of 3D bioprinting. Using cells as the ink, scientists are able to construct complex tissues layer by layer. While we're still some way off from printing fully functioning organs, the progress made so far is nothing short of extraordinary. But the applications of biomaterials don't stop at replacement organs. They're also being used to create advanced drug delivery systems, allowing for targeted treatment of diseases at a cellular level. This could revolutionize the way we treat conditions like cancer, potentially reducing side effects and improving patient outcomes. In the world of wound healing too, biomaterials have made a big splash. Bioengineered skin, for instance, is not only used for burn victims, but also for chronic wounds that do not heal with traditional treatments. These groundbreaking innovations are revolutionizing medicine as we know it. This is the 21st century where the line between biology and engineering blurs, where we're not just fixing bodies, but rebuilding them. It's a thrilling time to be alive. With all these advancements, one can't help but wonder, what's next for biomaterials? As we step into the future, the field of biomaterials is brimming with exciting prospects. The advancements underway are set to revolutionize industries and redefine our understanding of what's possible. Picture this: materials that can self-heal. Yes, you heard that right. Scientists are developing biomaterials that can repair themselves, much like our body does when it heals a wound. These materials could be used in a variety of applications, from building structures that last longer to medical implants that can repair themselves, thus reducing the need for invasive surgeries. But the innovation doesn't stop there. The future of biomaterials also holds the promise of smart implants. These are devices that not only replace a part of the body, but can also monitor and respond to changes in the body. Imagine a heart valve that could detect a problem and alert your healthcare provider, or a prosthetic limb that could adapt to your movements in real time. These smart implants could drastically enhance the quality of life for millions of people around the world. In addition to these, research is also being conducted on biomaterials that can mimic the properties and functions of human tissues. This could potentially lead to the creation of artificial organs, eliminating the need for organ donors and saving countless lives. But of course, with great potential comes great challenges. As we push the limits of what's possible, we must also ensure that these developments are safe, ethical, and accessible to all. The path ahead isn't without its hurdles, but with continued research and innovation, we can overcome them. So as we stand on the brink of a new era in biomaterials, we can look forward to a future where injuries heal faster, illnesses are detected earlier, and the human body can be repaired and enhanced like never before. The possibilities are endless, and the future of biomaterials looks brighter than ever. So, to wrap up our journey through the world of biomaterials, let's take a moment to look back at the key points we've covered in this video. We've traced the path of biomaterials, starting from their humble beginnings in the early days. We saw how these materials were first used in simple applications, gradually evolving over time as scientific understanding improved. We then delved into the development of modern biomaterials, a period marked by groundbreaking discoveries and innovations. The 21st century has seen an exponential growth in the use of biomaterials, transforming industries from healthcare to technology. Finally, we gazed into the future of biomaterials. As we stand on the cusp of a new era, the potential applications of these materials are limitless, promising to revolutionize our world in ways we can only begin to imagine. The next time you come across a biomaterial, remember, it's not just a material, it's a piece of science history that's shaping our future.